Good morning, everyone. I am Revati from the Department of Artificial Intelligence and Data Science. In today's session, we will discuss an important topic in machine learning analytics: evaluation model performance metrics. Building a machine learning model is only half of the task. The real challenge is determining whether the model performs well and it can be trusted in real world applications. This is where performance evaluation metrics become essential. By the end of this lecture, you will understand why model evaluation is necessary, different evaluation metrics for classification models, metrics for regression models, and how to select the appropriate metrics for a given problem. Then, why model evaluation is important? Machine learning models make predictions based on the patterns learned from the data. However, not every model produces accurate results. Therefore, we need evaluation metrics to measure the model effectiveness, compare different models, detect overfitting and underfitting, improve decision making, ensure reliability in deployment. Without proper evaluation, we cannot determine whether a model is suitable for practical applications. So, the types of a machine learning algorithms are performance metrics depends on the type of a problem. There are mainly two categories. One is the classification problem and another one is the regression problem. In the classification problems predict the discrete categories. For example, spam or not spam, disease or no disease, fraud or legitimate transaction. And then similarly, regression problems is used to predict the continuous values. Examples of regression problems are house price prediction, temperature forecasting, sales prediction, and the different evaluation metrics are used for each category. Next one is the confusion matrix. The confusion matrix is the foundation for evaluating the classification models. It consists of four components: true positive, true negative, false positive and false negative. True positive is similarly known as TP. The model correctly predicts the positive cases. Then true negative is the model correctly predicts the negative cases, and the false positive model predicts the positive when actually negative. False negative model, it predicts the negative when actually positive. For example, in disease detection, true positive means sick patient correctly identified. True negative case, healthy patient correctly identified. False positive case, healthy patient incorrectly marked sick. And false negative case, sick patient incorrectly marked healthy. Those values are used to calculate the several performance metrics. Accuracy. Accuracy is the most commonly used metric. So this is the formula for accuracy. Accuracy equal to true positive plus true negative divided by total proportion of correct predictions. That is, it represents the total predictions. For example, if a model makes 100 predictions and 90 are correct, then the accuracy is 90%. But the limitation in the accuracy is it may be misleading for imbalanced data sets. For example, if 95% of emails are non-spam, a model that always predicts non-spam achieves 95% accuracy but is practically useless. Therefore, additional metrics are required. The next metric is precision. So, the precision measures how many predicted positive cases are actually positive. So, this is the formula for the precision. So precision equal to true positive divided by true positive plus false positive. That is, the importance of precision is when false positive are costly. Examples of precision is email spam detection, fraud detection and recommendation systems. High precision means fewer false alarms. Recall or sensitivity is also one of the measure in the evaluation metrics. So recall measures how many actual positive cases are correctly identified. So this is the formula for the recall, that is recall equal to true positive divided by true positive plus false negative. The importance of true positive, that is the importance of recall in critical model diagnosis, cancer detection, safety systems. Missing a positive cases may have severe consequences. Therefore, high recall is often preferred in healthcare applications. The next measure is F1 score. Sometimes precision and recall conflict. To balance both, we use the F1 score. So the formula for the F1 score is F1 score equal to 2 multiplication precision into recall divided by precision plus recall. So the benefits of F1 score is it combines the precision and recall useful for imbalanced data sets and provides a balanced performance measure. A higher F1 score indicates better overall classification performance. Next one is specificity. The specificity measures the ability to correctly identify the negative cases. A formula for specificity is true negative divided by true negative plus false positive. So it measures the correct negatives and it reduces the false positive. That is mainly used in the applications medical testing, quality control and security systems. So high specificity reduces false positives. ROC curve. First, ROC stands for Receiver Operating Characteristics Curve. The ROC curve plots true positive rate and false positive rate. It helps evaluate the performance across different classification thresholds. A model with a curve closer to the upper left corner is considered better. Next one is AUC score. AUC means area under the ROC curve. The interpretation of AUC score is AUC equal to 1, that implies it means it's a perfect model, and AUC equal to 0.5 means it's the random guessing. Higher AUC values indicate better discrimination between classes. It is widely used in the applications like healthcare, finance and fraud detection. Next one is the regression evaluation metrics. Now let us discuss the metrics for the regression models. The common regression metrics include mean absolute error, simply known as MAE, and mean squared error, it is simply known as MSE. Root mean squared error, it is simply implies RMSE and R squared. These metrics evaluate prediction errors in the continuous value problems. Next one is MAE, MSE and RMSE. We'll see one by one. So MAE stands for mean absolute error, that is average absolute difference between actual and predicted values. That is easy to understand and interpret. A second one is mean squared error, it's simply known as MSE. It squares the prediction errors before averaging. Then large errors receive greater penalties. And RMSE stands for root mean squared error, that is the square root of mean square error. expressed in the same unit as the target variable. It is widely used because it is easier to interpret than mean squared error. The next one is R squared metric. R squared indicates how much variance in the target variable explained by the model. The range of the R squared metric is 0 to 1. Then the interpretation of R squared is 0 implies to no exploratory power and 1 implies to perfect fit. For example, R squared equal to 0.85. We assume R squared value is 0.85 means the model explains 85% of the variation in the data. So the higher values generally indicate better performance. Choosing the right metric. There is no single best metric. Choose the metrics based on the applications. So the medical diagnosis, it focuses on recall, and spam detection, it focuses on precision. Then the imbalanced data classification uses F1 score, and the regression problems, it uses the root mean square error and R squared. These selected metric should align with business goals and problem requirements. To summarize the model, evaluation is essential for measuring effectiveness. Then the classification metrics include accuracy, precision, recall, F1 score, ROC and AUC. Regression metrics include MAE, MSE, RMSE and R squared. The selecting the correct metric is crucial for reliable machine learning systems. Thank you for your attention. I hope this session helped you understand the importance of evaluating machine learning models and choosing the suitable performance metrics. Thank you.